Waec question 3 says, state the SI base units of the following physical quantities. Stress, force constant, Planck constant. I repeat, state the SI base unit of the following physical quantities: stress, force constant, and Planck constant. Let's move down to the solution. I would have just gone ahead to write the unit of stress, but for the sake of understanding, I am going to write or start from the SI unit, and from the SI unit we move down to the base unit. What do we mean by base unit? If you look at this, this is a derived quantity, and of course, for you to get a derived quantity, you have to combine fundamental quantities. So those units of fundamental units that makes up the unit of this derived unit is what the examiner asks us to do. So here we have stress, and the formula, if you can recall, is force per unit area. So any student who is bright would say, okay, the unit of stress is Newton per meter square, but the question didn't say write the derived unit. They need the combination of that fundamental unit that makes up this derived unit. So if you write Newton per meter square, at this point, since they said base unit, then it is wrong. So what you're going to do is that you're still going to break down further the units that you have here. So let's look at this again. Here we have force, and force is a product of mass and acceleration. So you now see stress equals to ma. Let me circle this so that you understand what I have written here. This is ma. This ma is in place of f. So that's the formula. Now the units here, for m, we have kilogram here, and then for a, acceleration, we have meters per second square. The area, the formula is still underneath here, but I'm still going to write it well. Okay. And it's not proper for us to write it this way, so I write it in the correct manner. So we had meters per second square up here. Mathematically, you can bring it down. So when you bring it down, this is how you will now write it, and then at this point, it's either you multiply or you cancel out. We have m squared below here, and we have m here. So m will cancel one of the m's here, and it will remain 1. So when you do that, you will now end up having kilogram all over m s to the power 2. So let's write it well. Kg over ms to the power 2, which could be written as kg m to the power minus 1 s to the power minus 2 from indices. So this is the base unit that the examiner asks us to write. The base unit. Okay, let's look at that of force constant. Of course, remember F equals to Ke. F equals to Ke. So the force constant is K. F is the force and E is the extension. If we make K the subject of the expression, then we have F over E. Now, what is the unit of F? It's still the same as the other F, Newton, and E is extension in meter. We break down further the force. We have product of mass and acceleration. Can still write it this way: kilogram ms to power minus 2 all over m. If you look at it carefully, you will see that m is common. So this cancel this. And then we arrive at this point, which is the final answer. Okay, let's quickly move down to the next one, Planck constant. For Planck constant, I will just go ahead and write the formula, and I break it down to the lowest term since you have gotten the idea. Okay, so Planck constant, the unit is joules second. Joules is a unit of energy. I would simply say, for understanding, energy, if I'm using work, unit of work, we'll have mgh. Okay, so this is energy times this is time. Okay, then you go ahead and write the units: kilogram meters per second square, meters, and then seconds. So this is what we are going to do. Basically, I had to do it as a rough sketch so that you get what I want to say. Okay, so kilogram meters per second square times m into s. Okay, so I've been able to break down the units here, joules, into basic units. You now see that we have m here and we have m here for the length, so we're going to multiply that. When we multiply, we'll end up having kilogram meter square over second square times s. Now you can see that we have s here and we have s here, so one s will cancel out one. I believe you understood what I said. If this one should cancel one of these, you end up having this expression here. And the next thing is for you to write it well. So in indices, we have kilogram meter square per second square. So we have come to the end of today's lectures. This is our home page, and if you are our subscriber, I will say thank you very much. If you are watching us for the first time and you have not yet subscribed, please do us a favor by clicking on the subscribe button, and when you do that, it will appear to be subscribed. Thank you very much for watching. See you in our next class. Have a wonderful day.